In the previous class, actually, what we have discussed is about the hardware part of a computer. What are the different hardware components that is necessary for the working of a computer? And we discussed about uh, the what you say, the architecture of computer, also the von Neumann architecture, and the six functional, I mean, the six logical components of a computer, logical parts of a computer. All those things we have discussed. We know that for a computer, only the hardware is not enough. We need software also. So what are the different classifications of softwares, or what are the different types of softwares that is required? That is what we are discussing today. The computer software is any what you say, any soft part, that is it is known as software because it is very soft. We cannot physically see it. So a computer hardware is useless, that we know, that is useless without any software. So the software is a set of, actually it is a set of instructions and associated data that direct the computer to do a task. So a software is a set of instructions that make a computer to do something. And in many cases, they not just the set of instructions, it need the set of data also. So computer software is a set of instructions as well as the associated data that direct the computer, the system, to do some specific task. Say if the task is to type something, that is create a document, we need a set of instructions to create that particular document. Then we need the associated data also, the data that is required to create that particular document. So that is that constitutes the software. Then the software is generally divided into two categories. The basic categories of softwares are the system software and the application software. The system software is the one which helps the computer to carry out its basic operating procedures or operating tasks, like booting up when you open your system, when you switch on your system, switch on your computer, whatever comes up, it is actually system software. Whatever is written inside the ROM, the read-only memory, is the system software. And when it is opening up, when a system is, or when a computer is opening up, whatever happens inside the system, it is because of the system software. Then the application software is a software which helps the user to carry out a variety of tasks, like the PowerPoint presentation, or Microsoft Word, or Microsoft Excel, or Adobe Photoshop, etc., Illustrator, then etc. They are the application software. They are used for specific purposes or specific tasks. It is not a generalized thing. So system software is required to run every application software. Without a system software, a computer cannot work. Without the application software, without a specific application software, you cannot do that specific task, but you can do all other tasks. If your system is not installed with, say, Microsoft Word, you may not be able to create Word documents. That is the only thing. But you can do all other works, all other tasks. You can program your new applications using this any programming language without this Word software, no problem. You can play music, you can watch movies, you can play games also. So that sort of things happen. So application software is actually not necessary for a system for a computer to work, but it is necessary for a specific task. So that each application software is dedicated to specific tasks. Now, this figure actually gives a basic idea about what is a software and what is the user, and how a computer works along with the user as well as hardware. So see, the outermost layer is user, that is the person who is working on a computer. So the user actually interfaces or interacts with the application software only. The user only interacts with the application software. So when I am working on this Microsoft PowerPoint, I am interacting with the PowerPoint only. I am not interacting with the what you say, the Windows. I am not interacting with the Linux or with the operating system. So the user is interfaced with, or the user is interacting with the application software only. Then the application software actually interacts with the user as well as the system software also, because the application software is dependent on the system software. Not all the application softwares can be installed on all the machines, all the computers, because of the system software. Some system softwares limits the installation of some specific application softwares. So then, so the application software has interfaces with the user as well as the system software. Then the system software has interfaces with the application software as well as the hardware. So the hardware has only an interface with the system software. So that is how it goes on. That is, inside the hardware, then the user is interacting with the hardware through the application software as well as the system software. So this is the types of system softwares are the operating systems. The operating systems like Microsoft Windows, Linux, Ubuntu, Mac, etc. They are the operating systems. Even our Android is an operating system. So operating system, then actually what the operating systems does is it schedules computer events. It schedules what event to do next, or next to next, etc. It schedules the computer events. The various events of the computer is scheduled by the operating system. Then it allocates the computer resources, various resources of the computer, like RAM, how much memory is to be used, how much time is to be dedicated for working of this particular operation, etc. So it allocates the computer resources. Then it monitors the events also, whatever is happening, whether it has happened successfully or there was a failure, like that. So the operating system actually does all these things. That is, it schedules, it allocates, and it monitors the events. Then there is another type of system software, that is the language translators, that is the interpreters and the compilers. So actually these language translators works along with the application software itself. Even though it is it comes under the system software, it is along with the some application softwares like interpreters as well as compilers. They are along with the application softwares. Then utility programs, some routine operations, something like sorting, listing, printing, etc. These are also known as the utility programs. They may not be falling under the system software category, but still it comes along with the operating system, etc. So like the printing of a machine, printing of a particular document through a printer. So that happens through the operating system. So for this this type of these operations, that is the printing operations, some specific programs are required, or some specific softwares are required, what we call it as drivers. They are the utility programs. Then like managing the data, they are also being done by the operating system. That is the managing the data, the creating files, merging files, or creating folders, etc., etc. Then the second type of software is the application software. So in the application software, as I said earlier, it is for specific purposes like Microsoft Word, Microsoft Office, all Office members like Word, Excel, Access, then PowerPoint, etc., etc. So these are application softwares. Then there are all the games that you say, they are application softwares. Most of the softwares that you use are application softwares. Even our that is Chrome, Google Chrome, it is an application software. Google Meet, it is an application software. So the application softwares may be a programming languages or an assembly language. Like these programming languages can be Fortran, Basic, PL1, Pascal, C. There are so many programming languages are there. And there are fourth generation programming languages are also there. So the application softwares are the softwares that we commonly use or on which we commonly work. Okay, so there are two types of software categories. One is the system software, in which is an operating system. Then the other type is class application software. So then what we are focusing is on software language. Why we are focusing on software language? Because we are going to study C programming. C is actually an application software which is used to create new softwares. So the purpose of C is to create a new software or code your programs, your applications in order to create C programming codes in order to generate new programs or new softwares. That is why C is used. So that is a specific category of application software, that is a software language. So the software language levels are actually, there are three different levels of software languages are there. One is a machine language. In the machine language, the complete representation, there are only zeros and ones. Everything is to be represented as a 0 or 1. Even the alphabets, even the operations that is to be done, etc., should be converted to zeros and ones. So that is a machine language. It is also known as binary language. Then the second classification is assembly language. That is, assembly language is a bit more higher level than the machine language. Actually, it has some sort of machine language component is there, but mostly it is more readable. The assembly language is more readable to human beings. The machine language, the problem is it constitutes of only zeros and ones. Thus, because of since it constitutes only zeros and ones, human beings may not be able to understand it freely. A novice user or a normal human being may not be able to understand the machine language. But the assembly language, some part of it is easy to understand. It is it is written like some words, some new, alphabetical elements will be there. So the assembly language, what does is when a program is written in the assembly language, the assembler is a specific software which converts this assembly language part into the machine language. So the machine language is the language which the computer understands. The computer or the machine or the system understands only the machine language. So that is why it is known as the machine language. No other language, computer cannot understand our English or Malayalam or Sanskrit or whatever language it is. The computer doesn't understand it. The computer understands only the machine language, that is the binary language, that is zeros and ones only. So the assembly language, what it does is we write the programs to a much to a higher level of human readable form. Then the assembler converts this particular language, code into programming code into machine code or machine language. Then the third level of software language is high level language. The high level languages examples are C, Perl, Shell, the MATLAB, etc. High level languages. The high level languages are the language in which the humans can easily understand the things. Like it includes the words which is commonly available in this human languages. Like in C, there is printf, which is easily which can be easily understood. Printf. So that is a command. So that sort of words are used in the high level languages. Then the high level languages, but the problem with the high level languages is that the machines doesn't understand the high level languages. What the machine understands is only the machine language. So what the high-level languages has to do is it has to be converted to the machine language, or it has to be converted to zeros and ones. Whatever code we write in C or Perl or Shell, MATLAB, Python, or whatever language it is, we have to convert it into the machine language, that is zeros and ones. Then only the computer will understand the thing. So in order to convert this high-level language into this machine language, there are two different ways of converting it. One is a compiling. C and C++ are examples of compiled languages. So we will see what is a compiler and what is an interpreter. So then Perl, Shell, Python, MATLAB, etc. They are examples of interpreted languages. So compiled languages is there and interpreted languages is there. So the system software languages are mainly classified into machine language, assembly language, and high-level language. These two, the first two levels are known as the low-level languages also. That is, the machine language as well as assembly language are commonly called as, or together called as the low-level languages. So the high-level languages are the language which can be understood by the human beings, which is readable in the human readable form, which is readable for human beings. So we have already said that is machine language. It is the first generation programming language, in which it is the language which is understood by a computer. It is a collection of zeros and ones. The only disadvantage, there is a disadvantage with the machine language. A machine language is not a standardized one. It is different for different CPUs. That is, there are different types of CPUs are there. Pentium CPU is there. Then another Pentium also. I mean, not Pentium. Intel CPUs are there. For different Intel CPUs itself, there are different types of Intel CPUs are available. So for each CPU, the machine language is different. The machine language can be different. So that is very difficult. That is a disadvantage. It is not standardized. So different CPU needs different types of machine languages. And the other one is writing in machine languages. It is a very slow as well as labor intensive as well as tedious process also. We may not be able to completely understand what is what a specific line of code in the machine language says. So it is very slow and labor intensive. Then the second generation, that is the assembly language. It is one step above the machine language. It is the second generation of programming language. As I said, it is more readable form. Then the computer operations are represented by mnemonic codes rather than binary numbers. Mnemonic codes are some alphanumeric codes like AB5. That is a code. That may not be a code in programming language, but it can be taken as a code. So then some code like OS 16. So that sort of codes, some sort of codes are used in the second generation assembly languages. Then in this case, the variables can be given names rather than binary memory addresses. So the variables can be given with the names. Say there is a variable X. It can be given a specific name in the case of assembly language. But in the case of machine language, only the address can be taken. So that is the difficulty. So then in the assembly language, the programmers could substitute language like acronyms and words such as add, sub, and load in programming statements. So these type of mnemonic codes or acronyms can be used in the case of assembly languages like add, subtract. Add is for addition, sub, sub for subtraction, load for loading a specific program, etc., etc. So a language translator called a compiler converts the English-like statements into machine language. Or this compiler is also known as, in the case of assembly language, the compiler is also known as assembler. So a language translator, which is a compiler or an assembler, converts this particular English-like language. It is not English or it is not completely human readable form, but it is a better understand. It can be understood in a better manner than the machine language. So the disadvantage is, again, this is also CPU dependent. A code, a specific program written in the assembly language for a specific CPU may not be useful for other CPUs. So it is CPU dependent. And the third generation or high-level languages. It combines the algebraic expressions and English symbols. So for addition, you don't have to give ADD or some code like that. Instead, you can directly write a plus for addition, minus for subtraction, etc. can be used in the case of high-level languages. So there the high-level languages are called so because each statement in this language generates multiple statements at the machine language level. So in the case of a high-level language, if you write one line of code, in most of the cases, that particular one line of code is converted into multiple lines of codes in the case of machine language. So that way of conversion is necessary also. Then the condition with the high-level language is it requires much faster, more efficient compilers or interpreters to translate higher-level language into machine codes. So the high-level languages requires a faster compiler to translate this higher-level languages into machine code. Only the machine code can be run in a computer. So the advantage of this high-level languages is that it is not CPU dependent, it is CPU independent. Any type of CPU can be used or can be used to create a high-level language or a program using the high-level language, whether it is in the Intel machine or it is a Mac, whatever it is, you can use the same high-level language to create a specific program, and it can be converted into the corresponding machine language. The disadvantage of this one is the computers do not understand it, so that some sort of an interfacing is required between this high-level language and the computers. That interfacing is the compilation or the conversion of the high-level language to the machine language. Okay, now some differences between low-level language and high-level languages. This is important. This particular topic is important. What is the difference between high-level languages and low-level language? That is an important question in the case of examination point of view, in the case of examinations also. So a low-level language is a computer language which consists of mnemonics that directly correspond to machine language instructions. That is a low-level language. And a high-level language is basically a symbolic language that use English words and or mathematical symbols rather than mnemonic codes. So that is the difference. In low-level language, mnemonic codes are used, but in the high-level language, symbolic languages are used. Then the low-level language is very close to the machine language. It concentrates more on the machine architecture, what type of machine is there on which this particular language has to work or this particular code has to work. That is about the low-level language. But in the case of high-level language, it is machine independent and it is a machine independent programming language. It will concentrate on the logic of the problem only. How this particular problem at hand is to be solved. That is where this high-level language concentrates. But the low-level language concentrates on the machine architecture. So that is a difficulty. That is a difficulty in the sense that when a human being is to be solved a particular problem using low-level language, he has to concentrate on the logic of the problem as well as the machine architecture. So that is difficult. So programming in low-level language is very difficult compared to programming in high-level languages. So then the low-level languages are machine language as well as assembly language. Both are together known as the low-level language. The high-level languages are Fortran, C, Pascal, C++, Basic, Java, whatever programming languages are available nowadays. They are high-level languages. So this picture represents a representation of how these things works. That is, a hardware is at the bottom level. In order to make the hardware work, you need the machine language, and the machine language, the assembly language is one step ahead, above this machine language. The assembly language is easy to convert into machine language. Then above this assembly language, it is a high level language. And in high level language, it is Fortran, C, Pascal, Basic, Java, MATLAB, Python, etc., etc. So many programming languages are there. So high level languages is then the program written in high level language is converted into machine language. Then this machine language will understand, the hardware will understand this particular machine language. So that is how this flow of hierarchy runs. So the difference between low and high level languages is one is in terms of understandability, then the ease of writing, then the running speed, as well as the writing format. We can see some examples also. The examples in the case of understandability, ease of writing, running speed, writing format, etc., etc. So the low understandable in the case of if we consider or if we differentiate the low level language and high level language in terms of understandability, the low level languages uses mnemonics, binary or hexadecimal representation of instructions as well as data. But the high level language uses simple English and mathematical symbols. So this particular picture represents what is what. So the right side represents the high level language and the left side represents the low level languages. The low level languages is understood by the computers, but the high level language is understood by the human beings. That's the difference. So this is a low level language code. So what actually it does is it adds two values. It adds 5 and 10 together. That is what it does. So this MOV EAX5, MOV EBX 10. What does this means that EAX is taken a value of 5 and EBX is taken a value of 10. Then add EAX, EBX is means this is being added together. So this is a low level language. It adds two numbers and stores the result. So that's it. Now this is a high level language. See, it is more understandable. In the main, so it is a function, but the code in which the 5 and 10 is added together is here. Int means integer value result is a variable, and into the variable result variable 5 plus 10 is stored. The 5 plus 10 is added together, then the result is stored into this one. So comparing these two different statements, in this statement, that is in the high level language, with a single statement you could represent the entire thing. But here, see, that particular thing required at least 3 different lines of codes to do the same thing. So that is the difference between the low level language and the high level language. Again, comparing the understandability, this is not that much understandable. We doesn't know what this MOV says, or this what model small whatever what it says, dot data what it says, we doesn't know, and they seems to be not required for the program also. So this is not that much understandable, but this the high level language, it is easily understandable. Then the ease of writing. The low level language, it is designed for the ease of the computer running the language. The low level language is designed for the computer. So it is easier for the computer to understand the things and the computer to read and write the things. But it is difficult for the human to read and write the low level language. But the high level language, it is designed for the ease of the person who is writing the language. And the human can understand. It is mostly most of the high level languages are using the English or English, even in some cases English like grammar itself. We are not using any specific grammar, There is actually grammar for programming languages. It is not the normal English grammar, but it is the grammar for the software languages or the programming languages is entirely different from the English grammar. But there are some set of rules by which you have to follow while writing this programs. So that is that can be considered as a grammar for that particular language. So using this high-level languages, the human can understand, but the machine will not understand. Then the running speed. The low-level languages are faster because there is no compilation required. The computer directly understands the low-level language, so it is very faster. It doesn't need any compilation also because it is in the obviously this assembly language requires some sort of compilation, but if it is a machine language, no compilation is required, and it is more efficient also. But the high level language, it needs a compiler or an interpreter to convert this language into machine language. It has to be translated into machine code, the high level language. So it is having a lower speed of execution. This lower speed of execution comes because it is to be converted or it is to be translated into machine code. So for a running example, see a low-level language statement. I don't know what that particular statement says, but some zeros and ones in the low-level language, that is in the machine code, only zeros and ones will be there. So the computer will easily understand it. It is an electronic circuit. It can understand zeros and ones far better than our ABCD. So the low-level language is understood by the computer easily. Then comes the high-level language. High-level language in 4 equal to 2 plus 2. It is easier for us to understand. But the zeros and ones, we cannot understand what that zeros and ones says. But we can easily understand 4 equal to 2 plus 2. So that is, then the running speed is also higher in the case of the low-level language. It is already in the machine-readable format. But the high-level language, it is not in the machine-readable format. It has to be converted first into the machine-readable format. So that conversion time or that particular translation time is also required for the high-level language. So that is why these high-level languages are slow. Then the writing format, the low-level language is set of instructions for the processor. The high-level language has some grammar rules. The grammar rules are the rules that is set for a specific programming language. It can be different for different languages. But in the case of low-level language, it is different for each CPU, each central processing unit, or each processor. The set of instructions will be different. So that is again the writing format. A hello world program. That is the system has to say hello world, or system has to display that two words hello world. So in the low level language, the hello world is this much statements, that is from model small to this end. So out of which this code is only this much. So this much data or this much lines of codes is required to display hello world in a screen in the case of a low level language. But in the case of a high level language, C hash, this is a C code, C programming. The first program that we will study in C is something like this. That is, we will be saying hello world to the entire world from our realm of C programming. So in this case, here we are directly printf hello world. It directly prints this hello world, those two words. Those two words is printed directly using only this specific command. So that is the easiness with which the high level languages can be handled. So the next topic is actually interpreters and compilers that we will discuss in the next class. So any doubts in this condition, in this particular topic, that is the assembly language, the machine language, the assembly language, the high level language, low level language, etc., etc.